Okay, we're looking at the guide system here for this made in China bandsaw mill, and there's two things that affect the blade and whether it's level or not. And when I say level, I mean level this way. If it's not level this way, when it attacks the wood, if it's on an angle like this, it'll climb up into the wood and then do funny things. It wants to be level this way, not just level side to side, but level front to back. And a couple of things affect that. One is the way they mount on the bandsaw wheels themselves. If the blade is running a little bit to the front or a little bit to the back and so on, that'll affect the orientation of the blade when it's running. And the problem is you have conflicting interests when you try to tighten the blade up and make it run on the right part of the wheel. You're told to make it so that the back of the blade is basically flush with the wheel, and there's instructions on essentially the way the wheel should be. And in this one, the blade behaves itself very well as far as staying on. I've never had a problem with that. But the blade is never right. And if you tweak it and tweak it and tweak it, which I've done a lot of, and after a while, you just make one cut, you check it again and it's not level, and it affects the cut. So I think this is the purpose of these items down here. This thing has a number of degrees of freedom for adjusting it, and the purpose of it is to be able to have it, these are guide blocks. Those black things there are guide blocks, and they're supposed to be able to keep it level, or that's the theory. But there's a number of problems with it. One of the problems is that this unit itself, it turned out in my invent, was not square to the blade. So when you tighten these up, these little guide blocks force the blade to be actually at a level instead of in level. But it seems to me that that's not the only problem with it. It seems to me they're inherently flawed. And one of the problems is that if the blade wants to be twisted, and you're not going to run it in there too long before it's going to make the blocks wear crooked. Besides that, you're not supposed to make the blocks right up tight. And I've loosened these up for now on this side, over and I guess on both sides. But you're not supposed to actually have them so that they actually touch tight on the blade. There's too much friction and too tight. So even if they were oriented right, and they're not, then when you tighten those, when you bring those down, there's still going to be a certain amount of opportunity for the blade to go the direction that it wants to, and if it wants to go at a square, it will. Now these are the same basic kind of guide systems they have on the vertical sawmills that you see in wood shops, and it isn't so much of a problem there, because if the blade isn't oriented right square that way, you actually are able to move the stock around and accommodate it. But on a bandsaw mill, the stock is stationary, and because of that, you have problems. So what I propose is that I'm going to take this whole apparatus out of there, and I'm going to approximate a bearing system that's in some of the better saws. In other words, I'm going to hack this, and I'm going to try to make a better blade guide system so I don't have the same kind of miseries when I'm trying to mill. Okay. Well, the first step in changing the blade guide system in this is to get the blade out of the way. So it has to come off. And then, for the sake of looking at what's going on, this is the part that has to be changed. I've already loosened the jam bolt, or whatever it's called, that holds it in place there. So that whole assembly, which includes a bearing and some guide blocks, come right out. And I'll replace it. I'll manufacture a new guide system with bearings instead of these useless blocks. The first piece of metal for that bracket is this angle iron. I guess it's 3-inch angle iron, and I've cut it I will cut it at 3 3/4 inches. That's the first piece. So it's a 3-inch angle both ways, and I'm going to cut it a length of 3 3/4 inches with my crude system here using a mini grinder. Too nice a day to be in the shop, so I rigged up the crude bench out here to work at. I'll spare you the grinding. Alright, I had to make a few modifications on this side. It appears the two sides are a little different. There's one pulley has a belt on it which gets in the way, so I had to cut a notch out there. I don't know what it is, inch and 3/4 maybe, or 1.5 inches. It's about 1 3/4 inches over, and it goes down about almost 3/4 inches. And you had to cut a little notch out of here, and I overdid it. You only need about, at the most, 1/2 or 3/8 inch notch over it. So this is going to mount like this, and this inch threaded rod will be in the back of this, and will go through the hole that this came out of. So you need to drill a hole, or you need to have some way. Maybe you can just weld it to it if you're good at it. I'm going to drill a hole in it, and I'm going to put that and weld that in place. And this needs to be about 4 inches. So I'll cut it off to 4 inches. I'll drill a hole and mount it. Alright, there's a hole drilled in there. And I've cut a piece of this, about 4 inches or so, and that's going to get welded in there, and that will go into the receiver that this came out of. Also, there's a nut here that's going to go on the inside of it, and since there's clearance issues, I'm going to split that nut down the middle and make it narrower, and then I'll put the full nut on the outside. That'll be obvious when we put it on the machine. Alright, this is what I used to get this inch threaded rod square to the bracket. I used the big nut on it to hold it in place and then just tack it. Alright, this is the way this assembly goes now. That rod is welded in there, and the thin nut goes on the inside for clearance reasons, and the thick nut will go on the outside and essentially go where that was before. There's going to have to be a slot cut in it yet, but for the time being, put that down and work on the next piece, the next part of the assembly. One thing I didn't mention about this was 3-inch angle. It is 3/16. And you wouldn't want it any thicker than that because it gets in the way. You might be able to get away with thinner if you're a good welder, which I'm not. There's more than one reason why I didn't film the welding part of it, in case they find out what I do with my welder and take it away from me. Alright, the next piece that's part of this assembly is a 2.5 inch angle. The last one was 3. This is also 3/16, and I'm going to just cut it off at 2.5, and this will be the part that slides up and down the other one to be able to push the bearing down onto the blade however far you want. So it's going to have bolts in it, and then there's going to be a slot cut in the other one. It'll be able to slide up and down in it. Alright, a little bit of update. Put the 2 holes in this second bracket that I made. They're about 3/4 of an inch from there over. One of them is right on the edge, and they're about 7/8 of an inch apart, something like that. All depends on how you cut it. And I cut a slot in there to correspond to it. So what happens now is this piece will go in there like that, and we'll have these, maybe plus a lock washer on them. See, that was not quite, had to notch that washer there, needs a little more notch on it. And this, the purpose in making this the way it is the slot allows it to slide up and down, so you can adjust the tension on your, against your blade, how far you want it up and down, and it's got play in it. And the way it's going to work is that play will allow you to set it so that you can adjust the blade when you're done, so the blade is level. Without that adjustment on there, you're stuck with whatever you have. So there'll be one more bracket go on this, like this, and this last bracket, and maybe I have it wrong there, but the last bracket will actually have the bearing on it. So I have to cut one more bracket and bolt it on there. So by being bolted on there, it has adjustment on it too. So you can adjust everything. I have one over here that's almost done. For the other side, the clearances were a little different, but it allows you. This is going to, when it's in the hole there, this will allow you to go. Which was okay. That's up. This will allow you to slide it up and down, and then these here are they're going to allow you to have some movement this way, so that you can adjust it the other way, and then the bearing will sit right in there. And so maybe I'll do another video when it's completed. All right, this is the last bracket, which actually mounts the bearings. So it'll go in like this, and then there'll be a spacer of some sort in there to keep the bearings from rubbing, obviously, not that thing, but some smaller. Then the bearings will go on there, and then another spacer, and it'll be bolted on place. So the thing now is to get this bolt, which used to be a bolt. I cut the head off it just at the right spot, hopefully. So to get it square, what I did, or to get it mounted right, what I did was take this piece of wood and put it in my drill press and drill it, hopefully at the right, straight up and down. And then this here will hold that in place, and that'll go on there, and I'll tack it with the welder, and then take it off and finish the weld. And I won't show you my welding. I'll show you it after, hopefully. All right, this is the assembly, and what goes on there next is a spacer to hold the bearing out from the backing so that it will run. And then after that, the bearing goes on, and then another bearing, and then another spacer to be able to tighten it up, and then the nut on it, and that gets tightened onto it. I'm going to take it off because it's hot right now and I don't want to melt the bearing seal. Anyway, this, when it goes together, goes in here, like that. And because it's made loose on purpose, it gives you, besides having adjustment up and down for putting the bearing up or down on the blade, saw blade as far as you want, it also has looseness so that you can move it side to side, and that allows you to make sure that your blade is running level. Anyway, I'll show it when it goes on the machine at some point. That one's nearly ready to go. Alright, final brackets are now installed. So the band on the bandsaw goes over, runs on these bearings. And the main purpose of putting them in is so you can keep it level. The back of the bandsaw now runs on this bearing here. So this bracket here was fastened to the main and original bracket. I just got it tacked on. I put a 1/2 inch bolt down, put a 1 3/8 as it turns out bearing on there, which I had because I didn't use it here. I ended up putting slightly bigger ones here, and that should work as the backing for it. So they're monster fucking things at this point, but they give me control. I was going to weld this, I was going to put bolts in and give some room for this to play, but in the end I thought I'll just set it in by eye and hope it's close enough that it'll work without running the band on it too much of an angle. I think it'll work okay. You do have one adjustment. You can take this angle here and put something on it and bend it if you go to that. Anyway, the next stage is to try it on the machine and to see how it works after all this work. Alright, just one more complication to add to this monstrosity. I put these bolts here, I just welded some nuts on there, and these bolts then go up and we'll go in and make a set spot for the sliding part. So as this part goes down, as you find your exact spot that you want for the bearings on the blade, you can adjust this. Actually, my plan is to go down until the bearing touches the blade and set that, and then there's another freewheeling out here, set it about 1/4 inch, and then turn it in another 1/4 inch, and do that on both sides, and you'll have hopefully the right setting for it. So I just have one more. That's one side, this one was the other because it was a little different. I had to put a longer bolt. And the other funny thing about it is the bolts are carriage bolts, and the reason they are carriage bolts is because I couldn't find locally any 3/8 bolts with any extension of thread. What happens is they just go so far with the thread and they leave the rest to be just shoulder. So maybe sometime I can replace this. I'd rather use the regular zinc bolt so I could get one with the thread on it, because then I could have a regular head on it up here for a wrench or socket if need be. And this could be, what I'd rather is this one that moves, I'd rather it was a lock nut, so it would end up staying where you put it. Anyway, it is what it is for now. So there's just one more thing I have to do. I have to put this on the machine as it is, see where it fits, and I have to put one more bracket on it to give the back bearing that goes against the edge of the blade, so that when the pressure goes on the blade, it won't push it past. You have to have a stopper, some kind of thing to stop it there. So there'll be a bearing going the opposite direction. Anyway, when I manufacture that, I'll show that as well. Alright, just a final little look at this unit on the saw. I realized I'd never really shown one close up in my other videos. So this is the new leveler, and one of these, I'll say that one of them came out of the unit, and this thing plugged in its place. And even though it looks rough and monstrous, which it is, the purpose was to give all these different bolts have different adjustments in it, so you could adjust everything on it. Essentially, these two here allow this whole assembly, it's in here, to slide up and down so that you can push the bearing down, up or down, however far you want against the blade. And it also has enough play in it so that this whole assembly also will rotate this way and allow you to level the bearing, which is your purpose in the whole thing. So this big bolt that goes right through to that first angle there is what holds the bearings, and there's another bolt. I'll change the angle on the camera in a minute here and show the back of it. But this here one, as I explained in another video, this allows you to set the height of it. So once you get it set so it's down where you want it, which is about 1/4 of an inch, I think, below level, then you can set this, and then you can basically tighten these a bit, and you can tap it until the whole thing's level. So if you tap it, you can move it this way and that way. These bolts up top allow the assembly to rotate this way, so that you can line your bearing up perfectly with the blade. Now, I'm not so sure that's necessary. I'm not so sure that it matters if there's a little bit of an angle on the blade that way, because it's so slippery, and I don't think it'd be a problem. In other words, I'm tempted to think that I could have done probably without this stage of it and got just by with one assembly, in which the whole angle would have been rotated that way, and this would have been hooked into this when it was rotated that way. But anyway, and on the back here you can see the little angle that I put on there with the backer bearing. It goes against the back edge. It's in there, so when the blade is in operation and it tends to push it this way, it's just slightly off the edge of that bearing now, so you can turn the bearing freely. You can't see it, but when the pressure gets on it, it'll go back and it'll push it, and you can see it turning a little bit and it goes against it. So that really does the same thing as the backer bearing did on this one when the blade was I guess this is probably the one here. After a while it makes you a little cross-eyed trying to figure out which way it goes, but this is the backer bearing, and those are the old guide blocks, which had no adjustment. You had no adjustment for level. It is what it is. But this one, the new one, does. Now, full disclosure on this, I've been generally pleased with how it worked, but I found that sometimes it tends to move a little bit, and you have to reset it. Now that all depends, I think, on how good a job you keep everything straight, so you can clamp that together well. And what happened, I'm embarrassed to say, on the other side, is that when I was tightening these bolts, they actually broke the weld, and I'm sure you couldn't imagine how my welds could break, but anyway, they did. And I was in the middle of, I'll move the camera over to show it. I was in the middle of sawing when it happened, and I had somebody here with me. And what I did was just weld it. So I'm going to stop this one, and I'll move the camera around a bit and show the other spot. The problem with these cameras is, when they're outside, you can't see the screen, so you don't know if you're focused right or not. But anyway, I don't pretend to be a cameraman. Just showing you the other side. And these two bolts on the back side there, one of them at least pulled through, I think, and lost my ability to hold it tight. So what I did is, I got it essentially where I wanted it and figured it was level, and I took my welder down and I tacked it there. And I wonder if that's not the best way in the end anyway, to get it where you want it somehow. You could make a lot simpler device, clamp it in place, maybe with some vice grips and C-clamps to get it where you want, and then just tack it. Once you get it level, it theoretically should be level, it should be alright. Now here you can see in this one also what goes on in the back of it. You can see that, I think you can see, this main bolt goes right through this unit. I put a big knot in the back and I put a skinny knot in here just because of clearance issues. And what that does is it allows you to move this whole assembly in and out that way till you get it where you want it. And these big threaded rods that went right through, they have a jam nut that goes in from the back of the frame here. So what I also had to do, I don't think I mentioned it on the video, is I had to grind a little flat spot on this threaded rod so that once you tighten it, and you can tighten it with this, but it's nice to have the jam nut in and hold it so that it doesn't move, and that part's worked pretty well, I think.